Okay, and see that is a lesson plan. The first class, that second, third, fourth, fifth, it goes on like that. Fine. Anyway, I wish very good morning to everyone. Right now, what is the first item? Number one, squaring of numbers. And see the squaring of numbers. Of course, squaring of numbers, everybody knows that is, but how many ways are there to find squaring of numbers? Sometimes if we get like 3-digit number, 4-digit number, we might find very difficult also. Of course, those type of questions will not happen, but still we must be knowing that is. And now we can see, that is in the squaring of numbers, and anywhere, see that entire the subject we need this is, you need to know the squaring of numbers up to 25 compulsorily, and cubes up to 11, and plus 21 cube, squares up to 25 must be knowing. It means something like this, so we have to by heart this, because questions are happening within that too. Any big number will comes, I will tell you what are the shortcuts of it like that. Now, because otherwise if we do not know, if we are not acquainted with the squaring of numbers, we consume time unnecessarily at the cost of another question. Now we have to write the squaring of numbers up to 25 right now. Squaring of numbers. Squaring of numbers. So, like 1 square 1, 2 square 4, 3 square 9, 4 square 16, right up to 25. Right up to 25. And even if you write even 10 times also helpful for you, that is, because up to 25 you should not find any difficult anywhere like that. That is essential part that is here. 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225, 16 square 256, 17 square 289. $289. 18 square, what is 18 square? 324. 19 square 361. 20 square 400. 21 square 441. 22 square 484. Okay. And 23 square 529, 24 square 576, 25 square 625. So this is essential for me, very essential. Okay. Otherwise you will have to spend unnecessary time on that exam hall. You are wasting time at the cost of another question. So, even if you write 10 times is also wonderful, because you may be knowing many things here, only some of the things you may not be knowing here, 13 square, 17 square, 18, 19, from 21, 22, 23, 24, 25, okay. So, this is the squaring of numbers, fine. So, this is, we know that, right. Again, the other thing is like that, this is squaring of numbers, write to cubes up to 11 cube, 11 cube we need to write. Cubing of numbers. cubing of numbers. Cubing of numbers. So 1 cube to 11 cube is necessary. There will be a question on 11 cube. Somehow it will come. Where is the population, calculation of population growth and compound effect like appreciation, depreciation, compound interest, it will come. 1 cube to 11 cube. Okay. So what is a 1 cube? 1. What is 2 cube? 8. 3 cube? 27. Like 4 cube? 64. 5 cube? 125. 6 cube? 216. This is a very shortcut for next finding the unit digit because 6 cube 11, 7 cube 343, 8 cube 512, 9 cube 729, 10 cube 1000, 11 cube 1331. So you will see the number suddenly 1331. So that should flash us. So we should recognize that is this is the 11 cube. Then you can start solving the question. Somehow one question will be there. How it comes, I do not know. There are many ways. Apart from that, you must be knowing 21 cube. 9261. 9261. So you must be knowing up to 25 squares, up to 11 cubes and plus 21 cube. This is very essential part. Okay. Yes, next. And now we can see 5 square. 5 square is what? 25, we know. 15 square, 225 also we know. And 25 square, what is the value of 25 square? 625. And 35 square, we find very difficult. It's like that. And what is our observation over here? This is the 25, 5 square. Okay. This is 5 square, last 2 digits is 25. And here 5 square, last 2 digits are 25. And here you can take 25, say. And now we can see, and 3 multiplied by next number, 12. 3 multiplied by next number. So if we take 45 square, first digit 4 into multiplied by the next integer. And the first part. And 5 square is the second part. It means what? 20, 25. 20, 25. And this is the part and parcel of Vedic mathematics. That will help us here like that. 20, 25. It means which of the following 4 options are given. You can think that which of the following is a squaring of number. It means to see the squaring of numbers, the last 2 digits must be 25. Then only you can try with that options. It's like that. And next you can see 55 square. 5 multiplied by the next integer, first part, and 5 square is the second part. This is 30 and 25. See that. See that. You can write for 65, up to 105 you should write. 6 into 7, first part, and second part 5 square. And what is this is 42, 25. It's like that. Because these are the areas where questions are being framed. 7 into 8 first part and 5 square. 56, 25. It's like that. And 85 square. 8 into 9 first part and 5 square is a second part. So 72 and 25 is like that. Okay. So now you get it. No? So now 95 9 into 10 first part and 5 square the second part. I think you get the logic, isn't it? And see the 90 and 25 like that. And see now 105 square is a 3-digit number. Okay, you just bifurcate into 2 parts. 5 can be separated from this and 10 into 11 and another 5 square. It means 110 and 25. This it means see, okay, this is possible only ending with the 5. Any number ending with the 5, it is like that. Okay, there are many things also we don't need so much like that. Okay, so now you can take what is say and the thing that is what is first item we said, that is how to make squaring of numbers, and see and what is say, that is sum of consecutive numbers I mentioned, that is sum of consecutive numbers. Now you can see that 1 square is what? 1. 2 square is 4. 3 square is 9. 4 square is 6. 5 square is 25. Let's see that. And so what is our observation over here? See, and what is the difference between 1 square and 4 square? Sorry, 1 square and 2 square? 3. 3 is the sum of 1 and 2 consecutive numbers. And what is the difference between 2 square and 3 square? 5. See, the 5 is the sum of 2 plus 3. It goes on like that. This is what we need. This is called shortcut. This is called shortcut. This is the way various questions are being designed. Say for example, you may need 11 square. You may need 11 square. 11 square we know now. We have been practicing, we know now. But 11 square, assuming that is we don't know. It means what? So you can take the previous number is a 10. 10 square is a very easy one. 10 square. What is 10 square? 100. 10 square is what? 100. So 10 square plus 10 plus 11. See what? 100 plus 21. So 121. So this is the easy one. Now we wanted to know the 21 square. 21 square. We don't know. Let us see, we forgot. And see the what is you can check the numbers which is having zeros. What is the previous number? Easier number? 20. Like 20 square plus 20 plus next number 21 is equals to 21 square. It means what? 400 plus 20 plus 21 is what? 41. So this is 441. This 421. So like that is what? So sum of consecutive numbers is the process like this. This will help us because this is a concept. Always we think that this is not SSC or IBPS exam. This CSAT exam means what? Logical thinking questions are framed where there is a concept. Where there is a concept. The questions are framed, questions are designed, questions are asked where there is a concept. Where there is no concept, questions are not asked. Like, now for example, you can say 31 square we wanted to know. Oh, what is the next process? What is the process of this? 31 square?
30 square.
Yeah, 30 square plus 30 plus 31, you will get 31 square. So, instead of writing so lengthy process, you can cut it. Okay. say 10 square, 10 square, it's like that. So now what do you say, 3 square, 30 square is mean 3 square you can take, 3 square, 9. How many zeros are here? 1. If you square, you will have 2 zeros. If there are 2 zeros are here, you would see 4 zeros. Plus 30 plus 31, 61. So 961. It's like that. And you can take like 41 square is what? 41 square. 40 square plus 40 plus 41. So then what is 4 square is 16, 2 zeros plus 81, and see that 1681. It's like that. Now you write for 101 whole square. You write for 101 whole square. 101 whole square. The questions are asked here. I do not remember which year and which paper. 101 square. 100 square is made what? 4 zeros will happen. 100 plus 101, like that. So what will happen? 201. 10,000, 201. See, like that. Otherwise you have to take how much time it takes to multiply. And we should agree that is, everybody must agree with me, because we have forgotten tables. Yeah. Fine, even we don't know tables, we should be able to crack it, that's all. So that is how it will happen. Any number you can do is like that, okay. So this is right, this is the sum of consecutive number. It goes on like that. What you should do, you should write till 100 like this. Then you will be very fast enough additions and subtractions. That is what is required here. That's why it is called basic numeracy. Again I am telling, all basic numeracy this is. No question is asked with the help of formula base. Formula based questions are other exams like railways, SSC, IBPS, like that. Here formula they don't come. Even there is a formula, you see the concept. Mentally you have to do that. Is okay. Yes, next one. And this is 1. Okay. And another part is what? That is a plus b whole square formula. A plus b whole square formula. You may be knowing also, I don't know. Right. For example, 11 square. 11 square. You divide a plus b. The 11 can be written as 10 plus 1 whole square. Okay. So this is a plus b whole square formula. What is a plus b whole square formula? A square plus 2ab plus b square. You take like this for our comfort. I'll tell you. I'll tell you later that is. Now this is a 10 square plus 2 into 10 into 1 plus 1 square. It means 100, 20 plus 1, so 121. See that. This is required for a CSAT, especially CSAT we need here. I don't know how the questions are designed. For any number you can do like this. But my advice is that is, you see that is the round figure numbers, you can see where you get zeros like that. For example, see like 25 square, we already know 25 square 625, isn't it? Now do it in a plus b whole square formula. You can say 20 plus 5, 20 plus 5, 20 plus 5 whole square, right? You can do that is, or even you can do 21 plus 4 also. See, 21 plus 4 whole square is also same, and you can also do it 22 plus 3. Any form you can do, but if you do 21, 22, we only find difficult. Additions and subtractions and everything will come. So you can take round numbers, 10, 20, 30, 40, 90, 100, 200, 300. That is easier for us. Otherwise, we can use normal traditional calculations. That is how it can be done. This is the a plus b whole square formula. Even you can do it in a minus b whole square formula also. So a plus b, we put 20 plus 5. You can see a minus b means 30 minus 5. 30 minus 5. 30 minus 5 whole square. This is. And see what is the formula? This is a square minus 2ab plus b square. Isn't it? And 30 square minus 30 2 into 30 into 5 plus 5 square. And see, this is 900 minus 60 300. So like how much it will go? 65 300 plus 5 square. Okay, 600 plus 25, therefore 625. It's like that. Okay, so a plus b whole square, a minus b whole square. Right. Again, another method, quick working method. Say for example, like 25 square. It means in the traditional way, what we write like this. Traditionally, we do like this. First we do multiply with 5. 5 5s 25, 10 125, 50. 5 2 625. This takes unnecessary space. Fine. Arithmetic method, how you can do 25 square is equals to 25 into 20 plus 5, like that. So 25 into 2, 50 plus, okay, 0 is okay, leave it. 25 into 2, 50, 1 0 is there, put 0, and plus, okay, 25 into 5, 125, 625. Any big number you can do, one line you can finish it off. That is, this is the one. And take another number of our choice like that. So 31 whole square, 31 into 30 plus 1 whole square. Okay, in one line you can, how we can finish it, one line, because in the exam hall you don't get sufficient space there. One line you can finish it out. These steps you should not avoid, that is. So 31 into 3 is what? 93. 1 0 is there. 930 plus 31 into 1, 31. Like here there are 2 digits, you take only 2 digits here. 31 plus 30, 61. See that. One line it is your time. One line you are writing. This we need to develop this method. Not our traditional way, how we did in high school days. That should be avoided. You are wasting a lot of working space. For this, what you have to do, that is, you should do 21 square, 22 square, 23 square, 24 square, 25 square, like that. You have to do this process now. Now you can do it straight away. Now, for 5 numbers, already we know the 5 numbers, right? How do we write like that? 21 into 20 plus 1, right? 21 into 2, 42 means 420 plus 21 into 1 and 21, this is 441. See the one line you get. You can do it for remaining 4. 22 into 20 plus 2 It means 44, 440 plus 444 and 484 like that. And 23 square, 23 into 23, 20 plus 3. It means 46, 460, 23 into 3, 69. 69 plus 60, 129, so 529, see that. You are writing, finishing one single line. One single line, you are finishing it. It means you are saving a lot of space. Lot of space. You can choose the options much faster. Right. For example, 24 square. 24 into 20 plus 4. Right. So this concept is required for entire aptitude. This concept is essentially required. So 24 into 2, 48, it means 480. 24 into 4 is what? 96. 96 plus 80, 176. 1 plus 4, 5. It's like that. See, that is how we can do. 25 square, 25 into 20 plus 5. 25 into 2, 50 means 500 you can take, 125 you can take. So 625. 60. See that how it will come. For any number of your choice you can do that is. Okay. Right. This is the thing. That's the thing that is. And say for example, let us take some number of our choice like 125 whole square. Let us say that 125 whole square. It means you can take 125 into 100 plus 20 plus 5. It's like that. 100 plus 20 plus 5. Here there are two zeros. Zeros there is no problem. Very easier one. 125 into 1. 125. How many zeros are here? 2 zeros. Okay. Plus 125 into 2. 250. 250. 1 0. Plus 125 into 5. 125 into 5. So like 500, 625. 625. Now you can take first two digits, you can 25, 25, you can take 25 here. Third digit, 6 plus 5, 11, 11 plus 5, 16, 1 carry. Okay, 2 plus 2, 4, 5 and 1, 15,000. Already you will get the options also. You get the options. That's a split. Arithmetic process you can do that. But only you have to do what this method 21 to 50 you should do. Once you sit and do means all these concepts will be registered in our mind. That is something. Yes. Next, again, I just pick method. That is a Vedic mathematics process. Like a plus b whole square formula only. Now we can take, let us take some other number. 31 square. We write 31 into 31. This is a traditional method we do that. Or we can do a plus b method. What we can do that a square plus 2ab plus b square. We write like that. Okay. So instead you can do Vedic mathematics. This is from left to right we move. Vedic mathematics process you start from the right to left. So 31 square means what you can do, 31 square means, okay. Now we can say first you can take 1 square, right. Again multiply the numbers, multiply the digits within the number. 1 into 3, 3 into 2 because 2 is there, 2ab. 1 into 3, 3, 3 into 2, 6, right. And again a square is what? 3, 9. say 961 like that. So you can take 31 square like that. We write 1 square 1, 1 into 3 3, 3 into 2 6, and 3 square 9. 32 square, 2 square is 4, 2 into 3 6, double 6 into 2 12, carry 1 carry, 9 plus 1 10 like that. So this is the Vedic mathematical process. Okay, you may not require, but I am telling you this is only because it is there. Whatever it is there, I am telling, that's all. This is up to you. See, that is. But if you do till 100, you are expert in calculations. You will become very expert in calculations. So actually that is what we need here. So 35 square already we know the answer, that is. We did some time ago now. It means 5 square is 25. You write 5 and 2 will carry. Put only one digit. 5 into 3, 15, into 2, 30, 32, 30. 3 square 9, 9 plus 3, 12, 12, 25. Mentally you can finish it out. It means that will help you to choosing the right options without pen and paper. Without pen and paper. Only thing is you should do till 100, not beyond that. Beyond that we don't need. Instead of a plus, if you write a plus b whole square, it takes 4 5 steps. But this is one single line, you can finish it out. One single line, it is finish it out. It doesn't take not more than 2 hours for all steps like that, if you see that. After that, is so much of practice is not required. Only concepts we need to understand. We need to understand concept, we need to digest concepts. This is Vedic mathematics. This is our ancient maths. Only Western people, they have found a plus b whole square like that. Okay? Yes, that's right. But when you want to do a plus b, there should be only a 2 parts. You cannot bifurcate the number into 3 parts. Only for 2 parts. Right. And yes, what is an, I think squaring of numbers is over now. Okay, cubing of numbers also we did it now. Though I did not write, we have done it that. What is the next item? Prime numbers. Yes. Again, see, the prime numbers are very essential. You will have 2 questions will happen from prime numbers. 2 questions will be there. There will be a minimum to, otherwise without, if you don't touch means question paper cannot be made ready. These are the concepts actually, this is. Okay, prime numbers. And prime numbers. What is the definition of prime numbers? Definition of prime numbers. We need the definition also.
Divisible by 1 and itself.
1 and itself. So then 1 cannot be a prime number, which is divisible by 2 distinct factors. The distinct word you should use it. So far it is not asked. It may be like that. I do not know. Okay, right. So let us not take any chance like that. And even see, yesterday I was going through the last year and before last year papers. New topics were included. The topics which were happening in IBPS is included now. That's why let us not take any chance. Let us touch every topic. What is the definition of this? A number. A number. Okay. A number means any number. Here A means what? 1 or anyone. A number which is divisible by 2 distinct factors. two distinct factors. Factored by itself and 1. Okay, so known as a prime number. This definition you can write. Not by itself and 1, distinct factor, two distinct factors. That's the right word. So if you say by itself and 1 will also become a prime number. Here 1 is not a prime number. So distinct factors, two distinct factors. That's a prime number. Okay, did you write? Right. Now let us check that. For example, which are the prime numbers you can take? What are the prime numbers? You need to know prime numbers till 100. You need to know the prime numbers till 100. Prime number. See, for example, 1 can be divisible by itself and 1. Itself and 1, every number qualifies to that level. But what is the definition says? Two distinct. There are two factors. Fine. But there should be distinct factors. Here 1 and 1 are not the distinct factors. So 1 is not a prime number. Now 2 by itself and 1. Two distinct factors. So 2 is a prime number, like that. And 3 by itself and 1. Two distinct factors. So 3 is a prime number. It's like that. And 4 by itself 1 and 2. There are 3 factors. So 4 is not a prime number. And 5 by itself and 1. So 5 and 1 are distinct factors. So 5 is a prime number. And see, 6 by itself 1, 2, 3. There are 4 factors. So 6 is not a prime number. 7 by itself and 1. So 7 is a prime number, like that. If you take 8 by itself 1, 2, 4. Any even number is divisible by 2. First thing. Right. How many factors are there? 1, 2, 3, 4 factors are there. So 8 is not a prime number. 9 by itself 1 and 3. So again, so this is not a prime number. 10, any even number we need not to check also. So 2, 5, because any even number is not a prime number, first of all. Any even number is not a prime number. Prime numbers generally are odd number, except 2, every prime number is an odd number. Mentally we have to finish it up. Right. So the 11 can be divisible by itself and 1. There are 2 factors. So 11 is a prime number. But how many prime numbers will happen in the first 100 natural numbers? What are the natural numbers? Counting numbers. It starts from 1. In the first 100, 1 to 100 is like that. That is a terminology, we need to know that. If the terminology is known, answering the questions doesn't take much time. Okay, if the terminology is not known, we don't understand anything. What is being said in the question, what is being asked in the question. Now we can see. Okay, let us see how 12. Should we check for 12 whether it's a prime number or not? No, because it's an even number. I told you, except 2, every prime number is odd number. So we need not to take even numbers to account also. 12, let us not take. 13, yes, 13 is a prime number. 14, let us not take. 15 is a multiples of 5. Any number it will not come. Multiples of any number it is not possible. 16 even number, let us not take. 17 is a prime number. 18, let us not take. 19 is a prime number. 20 is a even number, don't take. 21 is a multiples of 3 or 7, let us not take. 22 even, let us not touch that. 23 is a prime number. 24, 25 is a multiples of 5, let us not take. 26 even, no. 27 multiples of 3. 28 even number. 29. 29 is a prime number. Next 30, let us not touch. 31, yes, is a prime number. 32, 33, 34, 35, 36, 37 can be taken. 38, 39, no. 40, no. 41, 42, 43 is a prime number. 44, 45, 46, 47 is a prime number. 48, no, even number. 49 is a squaring number, 49, isn't it? Multiples of 7. And 50, no, 51, 51 is a multiples of 3. Okay, so 52, 53, yes, 53 can be taken as a prime number. 54, 55, multiples of 5. 56, no, 57, no, 58, 59, you can take. 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 80, multiples of 7, 11. Okay. Yes. Okay. See, there are one that another concept I will tell you in that also. Okay. Because all interconnected, every chapter is interconnected here. Arithmetic is like this only. 70, where are we now? 80. 81 is a squaring of number, 9 square. 82, 83, 83, 84, 85, 86, 87, 88, 89, 89 you can take. 90, 91, 92, 93, 94, 95, 96, 97 can be taken. See that, 98, 99, 100. So how many are here totally? 25. This is very, a year before last year there was a question on this. Maybe 2 years ago, 25, 24, 23. Set of numbers were given. Option A 4, there are 4 terms, option B 4 terms, option C 4 terms, option D 4 terms. For anyone, it just gets confused by saying that thing. But all are odd numbers. There are 25 prime numbers. You need to write 5 times or 10 times also this is. This will help you cracking questions much faster than anyone else. You need to know the prime numbers till 100. 100. And also at the same time you must see that is what is the smallest 3-digit prime number. What is the smallest 3-digit prime number? So 101. Beyond that, no questions will be asked because it takes more time. Whichever the question consumes more time, questions are not asked except 1 or 2 puzzles they make like that here and there. That's all. Okay. So unnecessary questions will not happen. 101 is the smallest 3-digit prime number. Okay. And see, now we can see while calculating also, here I will tell you sum of the digits. If the number is divisible by 3, a number n is a natural number. Let us take n is a natural number. If it is a natural number, fine. If it is to be divisible by 3, it means sum of the digits must be divisible by 3. So it can be divisible by 3, multiples of 3 or 9 also. Say for example, which are the numbers we see that is like 123 by 3. Say yes or no. What we do that we go like this 123 like 3 4s are 12 0 3, let us take 3 1s are 3, yeah, then you will take. It's not. No, it's not required. See 1 plus 2 plus 3, sum of the digits What is the sum of the digits? 6. 6 is divisible by 3? Yes. It's like that. So that is a very thing. That's why when you taking about the prime numbers also, prime numbers counting also, which are the numbers we have not taken? For example, see, let us take 11, 12, 13, 12. Even number let us not take. 13, 14, 15 is multiples of 5. Everybody knows this. 16, 17, 18, 21. So 21 mentally you can do. 21 sum of the digits is what? 3 is a multiples of 3. Let us not take. 24, 69. So 9 plus 6, 15 is a multiples of 3. 87, there is a confusion. 87 is what? Sum of the digits. 8 plus 7, 15 is a multiples of 3. Mentally you can finish it out. Mentally you can finish it up while seeing the options also. That is the thing. Okay. Right. Okay. What are prime? These are the prime numbers. And how the questions are asked like that. See, we can solve this, even previous year's questions also. Fine. You can take one question, that is, and what is the? You can write the question. What is the? What is the sum of? What is the sum of digits? What is the sum of the digits of? What is the sum of the digits of the largest two-digit prime number? Yes. Questions are asked in CSAT, especially they talk about lot of things about digits, sum of the digits, difference of the digits. It will come like that. By seeing this question, people go panic. What is the sum of the digits of the largest two-digit prime numbers? Largest two-digit prime number is what? 97. 9. Sum of the digits, 9 plus 7, 16. Like that. It is 16. So that is how it will come. That is okay. Right. So that is, we need to understand the question. Okay. So next, the question is not asked this way. It's my own creation. This is right. And how many two-digit prime numbers are possible? How many? This is a question I am asking. How many two-digit prime numbers? How many two-digit prime numbers are possible? In the number system. In the number system. How many two-digit prime numbers are possible in the number system? 21. Yes. How? So there are totally in the 25 is there, up to 25. One-digit numbers are also included, two-digit also. How many one-digit prime numbers? Minus one-digit prime numbers. That is 2, 3, 5, 7, isn't it? It means what? 25 minus 4, 21. Right, that is like that. Okay? So, it's like that. Okay? That is a thing. Just I am creating and asking the questions. Right. Now you can see next question. What is the sum of digits? What is the sum of digits? What is the sum of the digits of the sum of single digit prime numbers? Single digit prime numbers. There are, you can see what is the sum and sum also you can see. always when you read our own mother tongue, Kannada, like Telugu, or like reverse way, you have to do that. So, what is the sum of the digits of? Sum of single digit prime numbers. Sum of single digit prime numbers. Sum of single digit prime numbers is what? 2 plus 3 plus 5 plus 7. So, it's what? 5 plus 5, 10, 17. What is the sum of the digits? So, 1 plus 7, see 8. They may go little further also. Then you can say equal to, they put like equal to 2 cube, 1 cube, 3 cube like that. They come up with like that, which is equivalent to 2 cube like that. This is a 2 cube number. Like by seeing the number, we should notice that. That is really CSAT. Okay, right. Next, right, next you can say what are the questions can be framed here, right? How many even digit prime numbers are possible? 1, that's all, okay? We need not write also, so simple it is also not possible, right? Yes, next one. Next, what is the next item? You can say that prime numbers are over now. Integers. Integers, okay. Integers is a very small topic, but right, you can see the number line. Number line. Integers, number line. What a number, always remember the number line. So this doesn't take much time, very few seconds only, that is. Number line. What is number line? You can see that is like you can take let us draw a line like this. Take this is the 0, okay? This is 0. Right. 1, 2, 3, 4, 5. Right. So this is plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. Here what? Minus 1, minus 2, minus 3, minus 4, minus 1. This is enough. This is enough. Questions we'll see later, that is. Right. And see, this is integer. This is integer. So, this is positive integers. Positive integers like that. This is negative integers. Negative integers. That's much. This is enough. This is really enough. This is. Okay, right. Only you remember that line, that's all. Okay. But just let me ask you one thing. I'm just trying to interact with you. But do you see how many, whether prime numbers are negative numbers or positive numbers? Positive. Don't you see the negative prime numbers? Isn't it? We know, at the same time we don't know. So prime numbers are always positive numbers only. It's a rule book says that is. There is no negative prime numbers again. If the question happens means it's a problem. We know, we don't know. We put ourselves into confusion, isn't it? Prime numbers are always positive numbers. You can write the point if you want, that is. You can add that point. Prime numbers are always positive numbers. Only you would see positive numbers and negative numbers only integers. But again, integers are full numbers, not in decimals. These are very simple things. This is decimals won't happen there. Like 1.5, 2.3, 2.9, 3.6. it is not integer. Integer means, that's why even in the notices also, take even CSAT, IBPS, any other government exam notices, there will be a punishment mark, no? 0.25%, 0.3%. They say that they will go to the next integer. Sometimes they, for example, 0.25% punishment mark means, negative marking means, if there are 5 errors, what is the total scoring? That is 1.25. They don't take 1.25. They go to the next integer. Anywhere they are cutting 3 wrong, put another 3 extra options. So it's like that. They say that's why we go to the next integer. They say integer, the word is used in even circulars also, notices also. That's why, because notice integers will not take decimals, less than 1, more than 1. It will not happen like that. Okay, that's right. Yes. Next. Now let us come to the prime numbers. What are the topics, prime numbers we discussed? That is there, twin primes. How many twin primes are possible? What is a twin primes? But question is not asked so far in any exam. Because this is a concept I am telling, I am covering everything that is here. Twin primes. Okay, twin means what? 2. We know that. Twins. What is the definition? Definition. See, what definition can be written here? The difference between two consecutive prime numbers. Prime numbers is 2. The difference between 2 consecutive prime numbers is 2. If you take 2 consecutive prime numbers, the difference must be 2, then it is known as twin primes. That in primes. That is a twin primes. Twin primes. Okay. Now the next question. Next, how many twin primes are possible in the first 100 natural numbers? Question. How many twin primes are possible in the first 100 natural numbers? Right. How many twin primes are possible in the first 100 natural numbers? How many are there?
So you should write 2 numbers also.
Yes.
For example, 2 and 5 are prime numbers.
Yeah, yes, you write the pairs, that is.
Pairs.
What are the pairs are possible? We need to know, no? We need to learn this. See, like 2, 3 is not, starting from 2 is not possible. 3 and 5. 3 and 5. And another pair, 5 and 7. Next another pair, 7, 11, 13. 11 and 30. You write like this. 13. Already numbers you have written, no? 13. 13, 17, 19. Next comes to 17 and 19. Okay. 19, 23, 29, 31. 29 and 31. Okay, 32, 33, 37, 41, next 41 and 43. 43. So the difference between these two numbers are 2. Right. 43, 44, 5, 6, 7, 9, 50, 51, no, 52, 53. 51 is a multiples of 3. 53, 59, 61. 59 and 61, isn't it? 62, 63, 64, 65, 66, 67, 68, 69, 70, 71 and 73. Okay. 73, 74, 75, 6, 7, 78, 79, 80, 81, no. 82, 83 is a prime number. 84, 85, no. 86, 87, that's multiples of 3. 89, no. 90, 91, no. Yes. So there are totally 8 pairs. There are 8 twin prime numbers. So these things should be registered in your brain. By seeing this, you can just go ahead with that. Okay. And what is your observation over here? If you look at all these 8 pairs, what is your serious observation over here? What is your observation? No? This one? What's your observation? We have written 8 pairs. What's your observation? Because see, every number all quite different to each others. Only in the first and second, 5 will take 2 pairs. The prime 5 will associate it with 3 and 7. That you can note one point. 5 is the only prime number which associates with 3 and 7 to make twin primes. I think this is a very serious observation. And apart from that, you can see what is the smallest pair of 3-digit twin primes. What do you say that? 3-digit prime numbers. The smallest pair. 101 we can take and 103. This is the smallest one. You can write it. One not one and 103 is a twin prime numbers. They may not go to that extent. Okay, let us know that is. Anyway, we are here to learn something, what we need to do. Fine. Beyond that, we don't require. Okay, there are so many things will happen. In my book, lot of things I put. 100 pairs I put like that. Yes, next. What is the next one? Prime triplets. What is that? You are trying to say something.
Next topic.
Then topic. No, natural numbers okay. Even that prime numbers, what is there? Is it that over? Prime triplets is there. Prime triplets. Co-primes. Co-primes, prime triplets. Okay. Let us finish prime triplets first. Co-primes again essential for us. Prime number and co-primes. So mind-boggling that is. Okay. Anyway, prime triplets. Triplets means you know that is a 3. 3 prime numbers. 3 prime numbers. Now let us see, like P1 plus 2, okay, and this one P1 plus 6, like, or prime 1 P1 plus 4 or P1 plus 6. Both combinations are possible. You can write this. Let us move on.
So definition is?
Yeah, this is the only definition you can say. If you write definition, it takes more sentences. All 3 are prime numbers only. The prime triplets. It's a prime triplets. And say how many prime triplets are possible in the first 100 natural numbers. Only till 100 we can calculate, not beyond. Now let us see now what are the prime numbers. You can see 2, 3, no, it is not possible. Another prime number 3, 3, 5, 7, no. And see 3, 3 you can write also, 2, 3, 5, I will write all the things, okay. Again next what, 3, if you start with 3, 3, 5, 7, 5, 7, 11. First we will write the triplets, consecutive 3 numbers. Next what, you start with 7, 11, 13, 11, 13, 17, and 13, 17, 19, 17, 19, 23, okay. And what another set you can see, if you start with the 19, 23, 29, 23, 29, 31, 29, 31, 37, 31, 37, 41, 41, 43, 47, 43, 47, 53, and next comes to 47, 53, 59, okay. Now you can see 53, 59, 61, 59, 61, 67, 61, 67, 71, 71, 73, 79, 73, 79, 83, 79, 83, 89, 83, 89, 97. So these are the triplets. These are the triplets, prime triplets. You write like that. You develop the practice. After that, it's not required. By seeing this, you can strike out the options also. These are the triplets. But which will qualify according to the rule? Plus 2 plus 4. Here 2, P1 plus 6. It may, from here if you see plus 4. Right, 2 plus 4 or 4 plus 2. Either is possible. Now 2 plus 3 plus, so this is not possible. 3, 5, 7, common difference is 2, 2, no. 5 plus 2 plus 4, this will qualify. Okay, right. And plus 4 plus, yes, this will qualify. And next, this will qualify. 11, 13, 17, right, and this will qualify. And this will qualify. Okay. And 19 plus 5, no, this will not qualify. Plus 6, no. And plus 3, no, this will not qualify. Plus 6, no. And plus 2 plus 4, this will qualify. Plus 4, no. And plus 6, no, this will not qualify.
Sir, in the definition,
Yes.
Why is
P1 plus, no, if you take for P1 is a difference is 6. From here if you see that is 4 is difference. It's a very funny definition that is. That's why. That's why I say that is plus 2 plus 4 or plus 4 plus 2. That's easier that is. And sixth, no, it's not possible. And 66, no, this is not plus 2, no, plus 6, right. 4, no, this is not. How many are there now? So 1, 2, 3, 4, 5, okay, 6, 7. ಇನ್ನೊಂದು ಎಲ್ಲೋ ಬರಬೇಕಾಯ್ತಲ್ವಾ, where we missed it. Somewhere we must get one more. 1, 2, 3, 4, 5, 6, 7. There must be 8. Like, see that. Did we miss anywhere like that? 5, 7, 11. 7, 11, 13, 11, 13, 17, okay. After 13, 17, 19. After 17, 19, 23. Okay, 19, if you take 19, 23, okay, 23, 29.
So 29, 31, 37.
29, 31, 37, because the difference is here 6, no?
Last year.
Yes, it's more, and
8.
there must be 8. There must be 8. Where we went to, like 31, 37, 41, 43. This we have taken, okay. 43, 47, 49. It will not come. 51 also. 51 is not, will not possible. 47, 6, 53. 47, 48, 49, 50, 51. 3. Yes, okay. 6, 79, 4, 83, 83, 84, 85, 83 plus 6, 84, 88, 86, 87, no, 88, 90, 89, 91, it will not come. 92, 93, no. Okay, I think there are 7 is okay. Anyway, it will write.
Sir, 67, 71.
67,
67, 71, 73.
Oh, we missed that actually, no? 67, this we missed it here. 67, 71, 73. Yes, this take like that. Because I calculated this is. Because I put everything in my book, which is going to be completed. There are 8 pairs. You can remember forever, that is. Okay, so much we are writing only for our benefit sake. For the sake of our benefit. We don't know how the questions are designed. If you see the question, just they are adding new topics. Prime numbers, every institute or every mentor or every faculty will teach, but they do not go to the twin primes and all these things. There are 8 prime triplets.
Sir, 37, 41, 43, sir.
37,
41, 43. 71, 73, 79 ಆಗಲ್ಲ.
37, 41, 43. 31, 37. It is there, no?
Hello, sir. 37, 41, 43 pair ಬರ್ಲಿಲ್ಲ.
Ida 31, 37. Okay, if you take 31, 37,
Sir, ಅಲ್ಲಿ
31, what is that?
Sir,
20,
sir, ಅಲ್ಲಿ 31, 37, 41 ಅಂತ ಬರೆದಿದ್ದಾರೆ ಸರ್. ಅಲ್ಲಿ ರಿಪೀಟ್ ಮಾಡಿದ್ದಾರೆ. It should be 37, 41, 43.
ಮಿಸ್ ಮಾಡಿದ್ದಾರೆ.
ಮಿಸ್ ಮಾಡಿದ್ದಾರೆ.
37, 41, 43.
31, 37.
Sir, 37, 41, 43 pair ಬರ್ಲಿಲ್ಲ. 37.
Okay, which is not written 37,
41,
41,
43.
43. 37, 40. ಹಾಂ
ಅದು ಆಗುತ್ತೆ ಸರ್ 37 ಆಗುತ್ತೆ 71 ಬರಲ್ಲ ಅಂತ ಹೇಳಿ
71, 73, 79 ಅದು ಬೇರೆ ಅಲ್ಲ.
71, 73, 70. Yeah, this is not possible, no?
This is possible.
Yes. 31, 37, this is possible. Yes. Like, right separate. Yeah, that's fine. Totally there are 8 triplets are there. You cannot say 8 pairs, 8 triplets. The word you should supposed to use triplet. Even we will come and see that by the Pythagoras triplets also. Pythagoras triplets. So you can rewrite neatly that 8 triplets. So as and when you get sufficient time or relaxed time, you can just glance it. Oh, this is a prime triplets. If you make notes conveniently, no, it's good for you. That is okay. Making notes is a art. That is okay. Right. Next, what is the next? Co-prime numbers. Co-primes. You can see the definition. What is the definition of co-primes? Co means 2. In English, co is a prefix word. Refers to 2. Right. Co-prime numbers. See, what is the definition says that if SCF, that is highest common factor, is 1 between the numbers, in other words, in a simple way, in other words, both the numbers, both refers to 2 again, both the numbers must be divisible by 1 only. That's called co-prime number. You can write the definition, I will explain that. We will see the many examples of co-primes we need again. Rule of divisibility, this is it plays a vital role. Okay? Yes. Now, in other words, both the numbers must be divisible by 1 only. So that's a simple understanding. Yes. Next, if you take the numbers, say for example, like 2 and 3, let us take some examples of it. Examples. Let us take example A. 2 and 3. 2 and 3. Whether the co-primes are not are possible, we have to say that is. So 2 and 3, what is the common divisor? Common factor. What is the common factor of 2 and 3? What is the common factor of 2 and 3? Say, for example, 2 can be divisible by itself and 1. There are 2 factors for 2. 3 can be divisible by itself and 1. What is the common factor? 1. So 1 only will divide the both. This is a co-prime numbers. It's a co-prime numbers. See, if you take another example, let us say, like 3 and 6. 3 and 6. Like now if you take 3 by itself and 1, 6 by itself 1, 2, 3. What are the common factors for this? 1, 1. 3 also is there. What is the common factors? Common factors. What is the common factors for 1 and 3? What is the highest factor? 3. This is the SCF. This is SCF. Here the SCF is 3. So this is not the co-prime numbers. It means both the numbers must be divisible only 1 only. then is called a co-prime numbers. Now you can take C, like 4 and 12. Say yes or no. What is the SCF of 12? Even you can see, this is we checked it. For example, in a very clerical method we do like that. What are the factors for 4? By itself 1 and 2. For 12, by itself 1, 2, 3, 4 and 6. See 1, you see 1 here also. 2, see 2 here also. 4, you can see 4. What are the common factors? 1, 2, 4. Highest factor is what? 4. This is SCF is 4. But so much of work is not required. I will tell you one thing. What is the lowest number here? 4. 4 will divide 4. 4 will divide 12. The SF is 4. If the 4 will not divide, next you come to the lowest number 3. Check with 3. Like, for example, here what is the lowest number? 2. 2 will divide 2 but not 3. So next lowest is what? 1. That's a SCF. So it's a co-prime numbers. Now we can say 3 and 6. What is the lowest number? 3. 3 will divide 3. 3 also will divide 6. SCF is 3. If not, go to the next lowest 2 or next lowest 1. That is a thing. Okay. If you want to take example, I will give some more examples of this. Okay. You got it. This is all right. Next. Now we can see some more examples. You can see that like 17 and let me not go to 17. You have to tell me, if you take 2 as a number, what is the other number to be co-prime numbers? 2 and 3, right? This is the 2 and 3. Do you get to 4? No. 2 and 3 is possible, no? 2 and 3 is possible. If you see the 2 and 4 is possible, multiples of 2 should not happen. Multiples of 2 should not happen. 2 and 5, yes, it can be taken is co-prime numbers. This is the co-prime number. 2 and 6, can you take 2, 6? I said multiples of 2 is not required. If you take 6, that multiples of 6, the 2 also will divide the 6 also.
So 3 and 4?
3 and 4, okay. I'm talking about only 2, first number. Then write another number for our practice sake. 2 and 6, don't write. 2 and 7, yes, it is possible. And 2 can take 2 and 8. 8 is a multiples of 2 again, don't take. And 2, 9 can be taken. 2 and 10, don't take. 2 and 11 is possible. It means this is an even number, another must be an odd number. It's something like, okay. If you take 3, you can take 3 is what? 4 can be taken, okay. And 3 and 5 can be taken. 3 and 4. 3 will divide 3, but not 4.
So 3, the next number it should be greater than previous.
No, not necessarily.
3, 2
ಆಗ್ಬೋದು ಆಲ್ರೆಡಿ ಯು ಯೂಸ್ಡ್ ಇಟ್
3, 3 ಅಂತ ಕೇಳ್ತಾರೆ ಸರ್.
3, 3 you can take 3, 3. ಅವಾಗ SCF is 3. This is not the co-primes. Both numbers are divisible by 3. It's like that. 2 also you can take. Either way you can take. Not a problem. 3, 5. 3, 6 is not possible. Again, if you take 3, 6, no, it's not that. It's a multiple sum. Multiples is what? That's all. 3, 7, yes, you can take like that. 3, 8 can be taken. One even number, one odd number can be taken. So like that. But see that, like that you can take. These are the co-prime numbers. These are the co-prime numbers. Even you want to know find the SCF, highest common factor. What you can do? For example, let us take like 3 and 8. How to find the SCF? And one is okay, like that. And 8 can be divisible by lowest number. Largest number can be divisible by lowest number. See, 3 2s are 6. What is the remainder? 2. Again this becomes a divisor. This dividend should be taken here. Again 2 ones are 2, 1. Again this divisor will come here. 2 2s are 1, 0. The last divisor is the SCF. This is the process, division method. This is the division method. Because this is smaller numbers we can do. The larger numbers you have to go to the division method. For example, you can take for 2 and 3. 2 and 3, what is the largest number? 3, 2. 2 ones are 2, right? You have to do this process till you get 0 as a remainder. This is a divisor, this becomes a dividend, 1 2s are 2. What is the last divisor? 1, SCF is 1. So this is how the division method works out. But we need to know both. The numbers are bigger, we have to do the division method. Say for example, for example, say 17 and 27, we have to check. See, 17 will divide 17. If you take 17 as a divisor, 17 will not divise 27. Next, what do we do that? 16, again 15, 12. It takes hell a lot of time. So then you have to go to the division method, number 1. So 27 can be divisible by 17. So 17 ones are 17. What is the remainder? 10. The remainder becomes a divisor. This divisor becomes a dividend. 10 ones are 10, 7. Okay. And see 3. 3 2s are 6. 1 3 is a 3. Last divisor is 1. So this is the co-prime numbers, because this is SCF is 1. Again, if you know the prime numbers properly, 17 is a prime number. 17 prime numbers can be divisible only itself and 1. It's 17, the 27 is not the multiples of 27, again divisible by 1 only. By seeing this, you can tick the option. That's why I am telling, we must know the prime numbers till 100. Otherwise, we are about to lose marks. Questions are framed like that only. Questions are framed like that only, that is. Okay, yes. Next, if you take some another examples, if it like choice, if I ask 19, 38, okay, what will happen? What is the SCF of this? (38) is a multiples of 19. 38 is a multiples of 19. So yes, yes, this is SCF is 9, but this is not the co-prime number. It's not a co-prime number, not a co-prime. Like, if you write 19 and 39 is a even, see, this is a multiples of 3. This is the 39 is a multiples of 3. 3 plus 9, 12. Multiples of 3. Okay. 19 is a prime number. This is SCF is 1. So it is a co-prime. You will have some kind of a clues in that. It's not just solving the question, finding the answer. It's like a remote type of thing. It's not like something like history or geography. Okay, this is the mental applications. I normally emphasize that I tell every aspirant, first you finish the CSAT classes. The mind start functioning. The mind start functioning, that is. You have, especially you have some kind of some clue somewhere like that. And see, if there are 3 numbers are given, for example, and 23 and 29 and 31, what is a SCF? What you would do? Normal process is what? Division method. What is the largest number? 31, isn't it? 31 divided by the next largest, 29. Remainder is what? 2. Again this 29 can be taken here. 2 ones are 2, 9, 2 fours are 8, 1 and 2. So, right, 1. So, for this SCF is 1. When there is a 1, 23 again is one prime number. But so much work, we need to do so much? Why? Because all three are prime numbers. All three are prime numbers. If there is one prime number, but the only thing is you must see that is multiples of prime number should not be the pair. For example, see what I mean to say is that if you say 23, 29 and 46, you have to be very careful. 23 is a prime number, 29 is a prime number, 46 is there. 23 into 2, 46. 23 into 2, 46. So there we have to check it out, that is. What is the SCF of these three numbers? If you see 23 and 46, 23 is the SCF. For 23 and 46, 23 is SCF. 23 and 29, again is a prime number will happen. See that. For 46 by 29. 1. Five. Okay. So, and for this you will have SCF is 1. But this is the one odd number, one even number is there. You will get 1. And 23 and 1. Naturally, SCF is 1 only. That is. SCF is 1 only. Did you not?
Generally, we should make it 2 parts. If 3 is there,
first 2 numbers you have to take.
Out of that, which is the highest common factor?
Yes, because we checked it. This is the process of division method. First largest number and next largest. SCF is 1. When there is a 1, definitely 1 and 20 is 1 only. If there is a 2, you have to check with this number. You have to check with this number. So that is the part this is. It takes very less time. Right, that is a thing. And yes, the last we'll do one more question, like 15, okay, 14 and 28. What is the SCF this? SCF. What is the SCF of these 3 numbers?
Sir, in this you should take 28 and 15 first.
28 then 15.
Second largest.
Yes, second largest. Should be divisible by the second largest. If you apply the shortcut trick, apply, what happens now? 14 and 28 multiples. 14, this is the SCF is, here the SCF is 14. 14 and 28. SCF is 14. Even if you take like 14 and 15, so SCF is 1. Is 1. Okay, so that is. I did like that 14 and 28 are multiples.
Sir, I did it with 28 and 15.
Okay, 28 and 15, that is a tradition.
That is a
1 only. When 1 comes means again, that's all.
Then 15 and 14 I did.
1 only. When there is a 1, finish it. Okay. So that is a thing.
So 1 barley land.
There will be some other number 2.
So
You have to take common, ಅದನ್ನೆಲ್ಲ ಕಾಮನ್ ತಗೊಂಡು ಅದ್ರಲ್ಲಿ ಯಾವ್ದು ಹೈಯೆಸ್ಟ್ ಫ್ಯಾಕ್ಟರ್ ಇರುತ್ತೋ ಅದು HCF.
Yes. So you,
Correct.
Sir, one question
So which one, which is
Like,
multiplied by
if
which?
we pair any two numbers, it should not come one HCF like that. Is it?
No, not like that. Not like, because all the numbers, see, divisible by what is the largest factor, not multiplying. See, you are taking 28 and 15. What is the 28 and 15? First you take 28, no? 15 you are taking. One odd number, one even number is there. Even there also. One odd number, one even number is there. Normally you would see SCF is 1 for these two. Again 1 and 15. Naturally already there is a 1. SCF is 1. If it is 3, then it differs. You ask me, I will tell you, I will finish it. That is. Give me one example, I will tell you that. First you have to see any number is multiples of any other number like that. Okay. So this is the SCF. Wherever SCF is 1 is called co-prime numbers. Co-prime. We need, that is, even rule of divisibility we need to find that. Co-primes, prime numbers, the amount of prime numbers is essential, and co-primes is also so much essential. So that is a thing. Anyway, so okay, fine. We'll wrap up the program. Yeah, we shall assemble back again tomorrow. Okay, right.